Ian Henderson. Thank you to everyone who's joined the cryptocurrency or Tech for Sustainability live chat about Formula One and how Hewlett Packard Enterprise are working with the Mercedes Formula One team and doing all their data. And we're going to get some very cool inside stories about Formula One. I'm very, very excited. I already had a chat before with Ian, who really knows his stuff about Formula One and the Grand Prix and behind the scenes about drivers and everything that's done, and particularly how Mercedes have been so able to dominate the last few years, for the good or bad. But it's a very interesting story. So thank you everyone very much for joining. I'm super, super excited by this. Been smiling excitedly for a long while just to hear more about Formula One. So Ian, thank you so much for joining us. Ian is Chief Technologist for Hewlett Packard Enterprise, and he's been leading their relationship with the Mercedes Formula One team and working behind the scenes a lot with them on their data. Thank you very much to Tracer. So this Tech for Sustainability series is sponsored by Tracer. They're a connected value chain platform for the diamond industry. They're working on fostering a culture of innovation and working on encouraging sustainable business practice and ensuring customer trust in the diamond industry, and working to demonstrate provenance, traceability and authenticity of natural diamonds, and helping local economies wear their mines. So anybody can find out more. It's at community.tracer.com. That's community.tracer.com. So big thank you to Tracer. And Ian, thank you so much for joining us, and look forward to hearing more about Formula One and the Mercedes team. What can you tell us?
So thank you, Erica. No, it's a privilege to be here. So thank you for the invitation. So yeah, as Erica said, I'm a chief technologist in the pre-sales organization here at Hewlett Packard Enterprise. I've been with the company about 20 years, and I cover the manufacturing and utilities areas in the UK. But been really lucky over the last couple of years to have the opportunity to be the chief technologist leading some of the work that we're doing with Mercedes-AMG Petronas Formula One team. And I'd love to answer, questions. So fire things through. I'll answer them as I can. Obviously, I don't necessarily know all of the gossip, but in the technology areas, I'd love to see if I can help answer your questions. So just looking at excuse me 1 second. I'll just try that again. Just a quick video intro, just to give you a view of some of the things that we're doing with Mercedes first of all. So, a fairly quick video there, but hopefully you caught some of the text that's on that of the value of data and the importance of technology to Formula One. And, the little snippet that we see on the TV, if we're lucky enough to go at a race, you really don't get to see the amount of amazing technology that sits in the background, and, how they're continually pushing the envelope. In Formula One, if you're not continuing to improve, you naturally go backwards down the grid because everybody else is. So coming up 2.5 years, I think now ago, we started a technology partnership with the Formula One team. Clearly the most successful Formula One team of current times, 6 last World Championships, and looking on certainly off to a good start so far with this season, which has been quite a strange one. And if I look at some of the things that I've learned with working with them over that time, we work with them on solutions that are used at the racetrack, in the data center, work with our R&D, helping to evaluate different technologies for them. And I summarize the things I've learned with working with them is just around a couple of words really. So time is critical for everything that they do, and the priority for everything is how they make the car go faster, and everything is linked back to that. So any of the money that they spend with me, will get compared back to, it costs 150,000 for a new wing, and that might get them a couple of tenths of a second. What difference is the technology spend going to make? And I don't know how many of you are in an IT environment, but they really are a DevOps business. I haven't seen or worked with an organization which does things so quickly. They'll be looking at something that will change at one race weekend, developing a modification that's being designed, manufactured, tested, and shipped out potentially for a race meeting at the following event, just a week later in some circumstances. So really, really, really impressive. And the amount of technology behind it, we get to sort of scratch the surface in what we see outside, but the innovation and the attention to detail and the culture of the team, and I'll touch on that a little bit later on, has been really interesting. There's certainly a no blame culture. I remember one instance when James Vowles made a bad strategy call. I think it might have been Australia last year, and actually apologised to Lewis over the radio that a pit stop decision had cost him winning the race. So no blame culture, but the thing that I found that we went in was what stands behind that is a requirement to do a root cause analysis of anything that does go wrong. You can't make the same mistake twice. And I think some of that culture is what makes them so successful. And the size of the organization is interesting as well. So they've got about 1,000 people that work at Brackley, at the chassis facility. I think something like a similar number at the engine facility up in Brixworth. And the interesting thing for me, I normally work with large enterprise customers, very, very large global manufacturers, large utility companies. And, Mercedes is only 1,000 people in an IT team of about 30, the people that I liaise with. So more a small to medium business, but very, very heavy on technology. So what are the sort of things that I get to do in my CT role? So Eric was just looking at these pictures, and it says it just looks like I'm off traveling around the world with race teams. And unfortunately, I don't get to travel that much. What I do get to do is spend quite a bit of time at the factory, working with the team, looking at what are the technologies that they're using, how can we help them evaluate new things. So I'm, pre-COVID was certainly up there pretty much on a weekly basis, working with different teams. So the other thing that you can see that we do, obviously, we take the show car around the world. So I've done a number of keynote events, a number of large events around the world. And the photo in the middle there was one we did in Spain a couple of years ago, where we were lucky to get Toto and Lewis to join us for a keynote session, but also to come on our stand. And this was our country MD here in the UK interviewing Lewis, which was a fascinating event to be part of. And the work I then will do with the team is looking at, how are they using technology today? What have we got coming out in research and development so that I can trial new hardware innovations, look at the value they can get from data, how can they innovate? So examples, I've taken some of the algorithms that they're looking at for new analytics processes. We've taken those into our labs and tried them on all different sorts of hardware architectures, different memory technologies, looking at how do we get that extra piece of element of performance. And a lot of the compute that they have is heavily regulated. So they're limited in the amount of compute that they can buy for some of the simulation, and indeed limited in the number of hours that they can run simulations. Also things limited like the number of hours that they can run wind tunnel testing. So it's really important they get the most value from that data as possible. And it's been a real privilege for me to be able to get up to the site at Brackley. I've got reasonably free access, so that we're allowed to certainly move around within IT, a number of different areas like that. The only restricted areas where I can't go in unless we're being taken in for something specific is things like the wind tunnel or the simulator. I've spent a lot of time in the R&D facility up there with Rich Saxby, and I'll touch on that a little bit later. That was just a real eye-opener to me, to the attention to detail that these teams have. Actually, Erica, there's a question there that I probably can look at. So the question there from Richard, how will the new cost caps affect the ability to run data simulations, and how will the requirement to run these simulations openly available hardware and on openly available hardware impacts on the team? So there's a couple of restrictions. One is the amount of hardware they can buy. And in simple terms, that is the number of processor cores and the clock speed. It's a little bit more complicated than that. And they are limited in the number of hours that they can run. And that's all logged. And I think there are a number of changes. So today, that's only recording the simulation and not the pre-calculation. I think one of the restrictions that comes in next year is restricting that further. They're also restricting the number of hours in the wind tunnel. And I think there's some elements in the new regulations as well, which, depending on how well you're doing in the season, you will be allowed less of that time. So as you go through the season, you'll be restricted more than the teams that are further down the grid. So they're trying to level that all out. And obviously the car design is being changed quite considerably as well to reduce the impact of the wake that it builds to encourage better overtaking. That was supposed to come in next year. That's now been delayed to 2022. So, just briefly, and I promise not to do much of the corporate stuff, what are HP actually involved in, and why were we interested in working with the team? So we've changed our business considerably to be what we describe as edge-centric, data-driven, cloud-enabled. And I can't think of a partnership better than working with someone like Mercedes, who are absolutely looking at real-time analytics at the edge of their business. If you think of IoT, there's a massive sensors on these cars. How do they take that data? How do we look at how we can use things like machine learning to bring value to the team? How do they make appropriate use of cloud technologies, either that being a private cloud in the data center or a public cloud? So it's a really perfect partnership for us to work with them across all of the different parts of the business, and we've been lucky enough to be able to get involved in almost every element of the business. So really fascinating engagement. So if I'll talk a little bit about where does that start, the edge-centric piece at the racetrack, and just how much technology is there. Most of us, if we're watching the TV, will see, a dozen or so people in the garage. They all run out and change the tires, but what actually sits behind that? And they have, if you think of it in IT terms, it's the equivalent of setting up something like a regional data center and a branch office, starting on Sunday evening, getting it completely done in something like 48 hours, handing that over to production by Wednesday morning, running that as a mission critical environment through till Sunday afternoon, and then packing it all back up in a box tidily, ready to almost, at the moment, going week by week, moving somewhere else and starting that whole thing again. So they've got around 60 performance related people. They are limited to the number of people that can be at the track, and I think that's been further restricted this year with the COVID restrictions. All of those people wanting to look at data, right? So you'll see people that are sat in the garage looking at screens. There are trucks out the back with dozens more people looking at tires, oil pressures, all these different sensors, right? So there's over 300 sensors on one of these cars, even more during testing, and a massive data coming off that car. And they get some of that car as the car's going round. So some of that data comes over I think it's a 2 megabit link, so fairly limited link. That goes off to the FIA, and then they get fed all of their own data, and they get some of the data off the other cars, so they can see GPS data and other things, as you've seen displayed, I'm sure, on the TV. So they'll spend a lot of time looking at that data, at their own data, but looking as much as they can at the others. So you've probably seen comments where they've worked out, that Ferrari must have had 25 horsepower more last year, with the all of the engine modifications and the fuel modifications that they were alleged to be running on that vehicle. So they'll be looking at what tires are they using, how quickly are they using those tires up, how much fuel do they think they've got in the vehicle, how quickly are they accelerating based on the GPS data, and they can work out how much power that vehicle has, how well is the hybrid system working, all of those sorts of things. So real attention to detail, looking at what's the line that those other teams are taking, are they braking later? You've seen some of this discussion, but having had the ability to sit with some of the race engineers and look at some of those traces on the telemetry and the level of detail that they go to, I remember talking to them. It was so a couple of years ago, where Lewis had a problem, I think, in Austria. And you've heard over the radio where they say, can you slow down? And talking to the engineers, they showed us, I think it was when we were at Silverstone the week after, they actually showed us the telemetry and how they could see there was an issue building in the gearbox, and they could see he potentially only had 3 or 4 laps to make before the car might actually not finish the race. So, lots of people looking at that data. So they'll be pulling some of that data off as they go around the racetrack. When the car comes back into the garage, they'll be plugging effectively an Ethernet cable into the car and pulling next levels of detail off, right? So they have to negotiate and work out which of the sensor data do they want real time, how many of those, how many times a second would they want to see that data, and that's a trade-off between the different people that are monitoring the car. When it comes in, they get all of that data back, and looking at how they get the best from it. And if you think about when they're some of the qualifying recently to I think 6 thousandths or 60 thousandths of a second, between Lewis and Valtteri when they've been qualifying, you know, a thousandth of a second on some of these tracks is 6 centimeters. Right? So the margin of error is absolutely tiny. And one of the examples that we talked through with the team, I think was probably 3 years ago in Singapore. So these cars have got 300 digital sensors on them and one biometric one, right? And that's the backside of the driver. So the challenge between the race engineer and the strategist is to look at that data and try and interpret what the driver's telling them. So one of this issue that they had in Singapore was Valtteri was coming in and saying he was feeling a hesitancy in the vehicle at one point on the track. And the engineers couldn't see that in the data. So they programmed one of the buttons on the steering wheel and said to Valtteri, you know, press the button when you feel that. And he got it down to something like 100th of a second, and they could look at the data. And it turned out that on this street circuit in Singapore, they were driving over a bridge or a subway, and that was generating an electrical current in the car that was upsetting one of the sensors on the gearbox. So once they realized that was the case, they were able to shield that sensor and sort the issue. So, you know, that's just the sort of example of having to listen to the driver, look at the data, interpret that, and look at how that might change the way we set up the car. There's also, I say, a lot of equipment that rolls out. So we've got a mission critical platform. So there's actually 2 racks of compute equipment in the back of the garage. They run about 130 virtual machines, and they can run completely autonomously. Right? So if the communication's back to the factory, I think there's something like a 70 megabit link that they get back to the factory. If that disappears, they can do all of the work there. And then back at the factory, there's what they call the race support room. So there's something like another 30 or so people sat there listening to radio comms, looking at all of that sensor data, looking at strategy. You know, if you think of what's happening during a race, they're constantly calculating strategy, looking at, you know, what do they think the fuel levels in all of the other cars? How long do they think the other cars can go on those tires? What would happen if a safety car came out now? Right, and that's one of the things they'll have on these screens that you can sometimes see, where there'll be I'm not sure, I'll explain in a minute. There are a couple of screens there, some you can see and some you can't, but there'll be a little box that says that if the safety car comes in now, then it's probably time to box. So there's all this live strategy work going on all of the time, and that's being led by James Vowles, who you'll often hear on the radio talking to the drivers. So what do we actually install out there at the garage? So this is what they call Fantasy Island. So this is where you'll see Toto stood at the back of the garage. And this was originally when we were talking to them, they had some small format PCs running these screens. And I've actually worked with them, and we've put some high performance rugged workstations actually built into that furniture. So each of those screens now gets a quad core 3 gigahertz processor and a fairly big GPU to give these guys the performance they need. You know, when Lewis comes back in on a qualifying lap, they pull that screen down that they drop in front of him, he needs to be able to see the data instantly about, you know, where did he lose a couple of thousandths of a second on braking too late or not getting the power down early enough before he goes back out on that you know, final qualifying run. So it's really, really important to get that data through to the teams. The screen you can see, so that's the one that that'll allow the TV screens to look at. That will have things like weather forecasts and the fairly public information. And on these worktops, I think here, but certainly out on the pit wall, there's another screen underneath, and that's got all the data that they don't want you to see, all of the proper telemetry and other information. So they'll be looking down at that so that you can't see it. And all of the little red lights that you see along the bottom are actually the push to talk button. So anybody there can push that and talk to another engineer, and that sits back into the race support room that I'll show you a view of in a minute. So someone back in the factory in Brackley that might want to talk to a race engineer or someone setting up the tires can press a button and talk immediately to those different people in the team. So, you know, you think of the amount of IT that they've got set up that they have to build on that Sunday when they arrive, shipping this stuff all around the world. Well, I haven't put a picture of in here, and if any of you've been lucky enough to see what they call a motorhome that they build at the back. Now, that's actually a 3-story building with all of the VIP hospitality equipment. I think it's something like 20 articulated trucks or something. It may even be 30. Right? Crazy amount of equipment that is shipped to do not just the garage, but all of the hospitality and all of the engineering locations. So, you know, really, really impressive setup. And I had a great opportunity to go around and view all of that a couple of years ago at Silverstone when they were setting that up. So some great privileged opportunities to have a look behind the scenes. And then the race support room at Brackley, this is the view they have there, and it's a bit like, you know, mission control at NASA. So you can see each of the desks here has got, I think, three seats with 3 screens for each person. So you'll have Lewis's team on one side, Valtteri on the other. And again, looking at all of that data, looking at the condition of the car, looking at the strategy, tyre wear, all of those sorts of things. So huge attention to detail. You know, incredible amount of work that goes on. So the factory is a pretty busy place on the Sunday. And the engineering offices there, you can just see the glass window. You know, if they've had issues that they've seen or been testing a component or something through the weekend, they'll be in there at the weekend looking to design a modification or looking at what changes they can make to the setup for the car for the next event. So really, really impressive facility that they've got up there at Brackley. And just want to talk you through here the data value of this. And this is something that I worked on with Jeff Willis. So Jeff is the Director of Digital Engineering Transformation. And this is really looks back at the sort of conversations I have with my manufacturing customers. And in that space, we call it Industry 4.0, but it's really about the value of data in a much more closed loop process. So, you know, in the ultimate level, if you imagine a connected product. And it used to be, you know, that we would buy a product and the functionality of that product was finished when it left the factory. But, you know, that's changed now with connected products and the ability to change functionality through software. A product isn't necessarily finished when it leaves, you know, and I guess a great example here, probably at the extreme that did that first would be Tesla, you know, that continually adding new functions to the vehicle. I know Daimler and others are doing that now, but you know that a vehicle or a product can continue to change and develop after it's left, and that's something that's quite a new process. You know, and the value from taking that data and feeding that back into the design process, right? So how do I understand how the thing that I generated in the field or generated in the factory operates in real life and feed that back in a closed loop? Now, in most industries, that will happen from one product generation to another, or maybe minor revisions. And for me, the really exciting thing in Formula One is that happens from 1 week to another, right? So if we go through this loop and I look at analysis and design, if I start at the top, you know, going through last year, they would already have been looking at the regulation changes for the next year. So if you think of the DAS setup, the adjustable steering thing that Mercedes came out with, they were looking at the regulations and doing an interpretation of that. And you know, we found out recently, obviously, that they've been talking to the FIA for a year or more, checking that that was a valid interpretation of the rules and getting that agreement that they could do it. So looking at what are the rules, what are the things that are coming out in new technologies, you know, different hybrid powertrain technologies, different ways of building carbon fiber, and looking at all of the different design choices that I could take, right? And creating data as they go through all of this. So I mentioned at the racetrack, they're generating around 250 gig per car. With all of the video, it's something like 3 terabytes over a race weekend. With all of the simulation that happens at the factory, they can generate over 40 terabytes of data a week, right? So huge amount of data being created. And the reason a lot of that's changed, for those of you who followed Formula One historically, they were allowed pretty much unlimited testing. And the race teams would have a second team that were just out testing all of these different innovations on a physical vehicle. And the cost of that was prohibitive, and it meant that the lower down teams just couldn't afford to compete. So lots of regulation was brought in to limit testing. So they have very limited testing sessions. This year in Barcelona at the beginning of the year, I can't remember what's happening this season, but you know, typically a couple of other testing events through the year. So the process now is they'll go through that analysis and design, looking at what are the choices that I can make, and then they'll simulate it. So this is where we use huge compute power. So we've sold them compute platforms with thousands of processing cores where they will simulate, right? So they will build effectively a virtual wind tunnel. They will look at how the wind will flow over the surface of the car. For an individual component, they'll have a complete software model of the car and look at how that interacts before they build a physical model. Right? And there'll be a closed loop. I've drawn this as a very simple model, just saying I move from analysis to simulation. That'll actually be a closed loop going round and round and round, where we'll do a simulation, we'll go back, tweak the design, we'll simulate it, we'll tweak the design, we'll simulate it. Once they've done that simulation, they'll move on to validation. So they'll build a wind tunnel model, and it's limited. Their wind tunnel actually at Mercedes is a full-size one, but again, to reduce cost, they're limited to a 2/3 scale car. And this car, I was lucky enough to go into the wind tunnel recently and actually see some of the models, and I was just amazed at the level of detail. Everything works. The tires are scaled down and will compress the same, to the same percentage that they would. There's even a fan inside the car that generates the airflow to simulate the exhaust gases coming out over the back of the vehicle. Right? So it's not just a simple fixed model. It's a very functional model full of all sorts of sensors. The surface of the rolling road effectively rolls round, so like a big, huge belt, because of the interactions that can have with the tires and suspension, and what happens when the car moves. So very, very, very sophisticated. But they're heavily regulated on the amount of time that they can run that wind tunnel. So all of that fan time is monitored. So once they've done that validation, they'll take that back. It may go back into the analysis and design and simulation piece. So that area there can go, round in circles multiple times. So once they've understood that they've validated the design, and most of that work is aero, right? So most of the work that they're doing is aerodynamics. They'll come into test and development. So this is then a part of the facility, which I've spent some time there, I said, with Rich Saxby, who runs that part of the business. And here they will actually simulate all the different parts of the vehicle. So they will test things like the steering rack, the wheel guns, which are a work of art in themselves, full suspension components, and a full-size car, where they can hold the car, they can simulate the downforce by pulling the vehicle down, independent hydraulic rams that can move the suspension around, and they will simulate the vehicle going over the curbs. So in Austria, I think it was, they had some issues with the curbs causing some problems with some of the sensors early in the season. And they will have probably, I'm assuming, taken all of the sensor data from going around that racetrack and playing that back into a chassis to look at what did that mean to the chassis, what can they do to change that. And I think they openly said, they were very busy making some changes to the vehicle between the first and second races in Austria to try and address those sorts of issues. The other things they do in that test and development space is around testing the individual components for strength and life. They will have a life cycle. So a suspension wishbone or a front wing will have a life cycle of the number of hours that it can be on the vehicle. So they'll bring it back into the lab and they'll put it in machines to bend it, twist it, potentially to the point of destruction. And if they work out that actually they made it too strong, they'll potentially revisit that to go back in and make the component lighter. Right? Because the lighter they can make all the components, they can choose where to put the weight in the car to get the best balance. Right? So really, really fascinating to spend some time in there and look at the attention to detail to every different component. How does the tests they have to do to make sure the wings don't twist, and the location of all the sensors. You look at that front wing. Interesting to look at the detail of, they've got little pressure sensing tubes all over that and across the floor of the car to understand exactly how the airflow is working across that vehicle. And that's why, I remember Lewis had an event where a tiny bit of the floor pan was broken, something the size of a 50p piece or something missing out of the back near the rear wheel. And they can tell, I believe, from some of the sensor data of how much difference that's going to make to the vehicle. So whilst there might not be damage that's seen, they may have that level of detail coming off the sensors on the vehicle out on the racetrack to understand whether the vehicle's damaged, whether they need to tell the driver to make an adjustment. So, real attention to detail and getting value of that data all the way through. And the car setup, so, once that's been designed, there's still a number of choices then as we move on to the testing and simulation of different bits, and I'll touch onto a piece of machine learning in that space in a little bit more detail. But the car setup for the race, so we worked with them to build a platform to help accelerate that simulation. So if you can imagine, this year is probably even more critical, but the car changes from race to race. So the panels, the aero package that they put on the vehicle for Monaco is going to be quite different to Monza. right? So if you've got a slow speed circuit, you need a lot more downforce at lower speeds, but that trades off at higher speeds for more drag, right? So they have to get this balance between the right amount of downforce so that the tires aren't overheating and blistering versus the amount of drag that you're not slower going down the straight. And the car will change through the season. So it might look the same to you, but the car at the end of the season is quite different, right? The only bit that doesn't really change is the body tub in the middle. Everything else on the car has a good chance of changing through the season. So they have to run a simulation process to look at what's the right setup. So that's suspension setup, gearing, a number of different things. And that simulation used to take 4 days. So we worked with them to optimize that, look at which platform we could run that on, and we got that down to less than a day. So what that means now is you're leading up to that race, rather than running the simulation once and doing the car setup, we can run 2 or 3 simulations during the week for a wet race, a dry race, maybe different strategies of pit stop strategy. We can then run practice on the Friday and potentially run that simulation again overnight based on the track data to tune the car setup again for Saturday morning. So a huge amount of work goes on, even on the race weekend, to look at that data and get the best from it. And then when we come to racing, I touched a little bit on that earlier. We've got an awful lot of strategy work that's going on. We've got these edge compute platforms out in the Fantasy Island that I touched on earlier. I'm hoping that they're actually going to put those out on the pit wall for the guys out on the pit wall later for this season or maybe next season. That's something that we're looking at the moment. And, really needing to get that data to the driver for those strategy decisions. I mean, we were talking to Erica earlier on about the rules that have changed on and off between communication between the race team and the driver. And several years ago, they restricted that the race team couldn't give strategy updates to the driver over the radio, but they then all started using secret codes and different naming and things like that to get around it. So they've relaxed that they can, talk about different modes, different strategy now. But, they'll all be listening to each other's radio comms, trying to work out what the other teams are doing, who's going to do the undercut, the overcut, and constantly looking at that strategy, looking at the car data, looking at what they might need to change for that race or a future race. So the value of that data, if you look at that, then coming back into the analysis and design, looking at all of that data as we go through each event, feeding that back into what are we going to do for the next race or a race in a few weeks' time to try a different tweak on aero. We've seen over the last couple of seasons different wheel designs, different brake duct designs. All of these things being evaluated and tested to look at, how do we get that, few hundredths of a second, to make sure that we're keeping ahead. So really, really, fascinating view of how that data moves through the business. And there's a number of areas that we work with the team to look at how do we take advantage of technology, and I touched on a couple of those, and one of those was in machine learning. So like a lot of companies, Mercedes and some of the senior management there were skeptical of the value of machine learning. They certainly won't call it artificial intelligence. But what we've done, I didn't mention actually at the beginning as part of this partnership, so we've embedded effectively 4 people in the team. So my role there is part-time, if you like. But we've embedded a program manager and in particular a data scientist into the team. And he's been, really gone native and working with them and looking at how do we help them evaluate how they could take machine learning, how they could productionize that and get value from it. And some of these are sensitive to the performance, so we can't talk about exactly what they are. But in this case here with Jeff, we looked at one of the design simulation elements as part of the design process for the vehicle. That was something they were doing reasonably manually, I believe, looking at a number of images that were generated, and that was taking them a number of weeks, I think something like 6 weeks. And we've automated that process. I mean, we're saying 90% time saving here. I think Matt Harris, who's the IT director there, said it came. I think we got it down to a day, but they still looked at the images, and it took a week because they wanted to validate that what we'd done on the machine learning was true. Right. So really, really fascinating view of how we can take machine learning and apply it and give them, you know, if you think of the design cycle of the car, shrinking and giving them an extra 3 or 4 weeks of time in the design cycle to look at the different options and the different things that they can potentially simulate and bring into that. As an example, you know, these are the sort of approaches that have helped them continue to be, you know, the dominant force in Formula One for the last few seasons. And I think for me working with them, and it's been really fascinating. And I mentioned earlier that culture of the team, and that everybody has a voice. You know, so I've seen in the IT team where I work, and I'm pretty sure it's the same across the factory, that if anybody sees anything that they think can make an improvement, they can fill in a card, say what that suggestion is. It's reviewed by management, and then people are fed back on whether that was seen and moved forward, or the reason they didn't adopt it. So everybody has a voice, no matter where they are in the organisation. And that tied up with this root cause analysis of the way that they work of, you know, if something goes wrong, we've got to understand why. And we were told that was something that they had with another vendor that had worked with them before us, where there'd been an issue with the component and they just replaced all the components. And they said, well, that doesn't help. You know, it can happen again. We need to understand why it went wrong and ensure it doesn't happen. So when you look at that culture of openness, the way that they work, you know, the hunger to work there, the hours that these guys put in, particularly in the aero teams, you know, the stories I've heard of you know, why would you do that? Why would you put in 80 hours a week that they might do at certain times of the season to get a new design or a new option out? But they're getting to work on technologies at the absolute pinnacle. You know, if they were working in an aerospace or a defense customer doing carbon fiber, there's no way they'd get to do some of the things that they get to do and the solutions they get to do the analysis on. So really, really fascinating team to work with. It's been, you know, amazing opportunity for me and the other guys in my team to work with them and see how they really push the envelope on those technologies and help us develop things for other customers. And, you know, the other area where we've been helping them, I've talked mostly about the technology, but a lot of what we do is in the boring back office piece of IT. And, you know, there's just one of the head of operations here, Chris Green, that we work with. You know, I said they got quite a small team and they all know elements of the solution, but maybe not as well documented and automated as they might be. So we've done a lot of work with them to look at how do we help them build what they describe as an autonomous data center where they're not completing manual tasks. So how do we understand and bring automation into the tasks that they complete every week so that can be immutable? And so if you can imagine that they arrive, if they have an issue at a race event, that they don't try and debug that issue with an application. They basically press a button and the application is refreshed and a new instance is stood up, right? So that they don't update and do any modification of fault finding, they just redeploy. So reducing time, improving quality in everything that they do. So there's a lot of stuff that we've done in the background, looking at how do we help them become more efficient and free up the time that they're spending working on keeping IT and the lights on into spending that time on things that make a difference to the team. Where can they do something that makes IT more relevant to the organization? And I think, you know, that's the sort of value that it's given us working with them as technology partners to take that back into my traditional manufacturing customers who, you know, don't work at that pace, but have similar challenges, right? How do we help them address the issues of technical debt and legacy, become more agile? How do you bring innovation in? You know, that lesson with machine learning, you know, I do a lot in manufacturing looking at IoT and different digital use cases. And these things end up being proof of concept purgatory, right? So you do a small proof of concept, prove it's something, but don't move it into production. So I think, you know, what I've learned from working with the F1 team is because they're a DevOps business, that they'll be able to take those technologies, adopt them, and move them in production much more quickly. So, you know, there's a lot of lessons that we've learned from working with them that we can apply back into the customers that I work with on a day-to-day basis. So that's the sort of end of the piece I was looking to cover, Erica. I haven't seen any other questions come through, but I'd be
no, amazing. I've had a few text to me a cheeky one about what needs to be done so that Ferrari in specific can catch up by a guilty party in the listener group. But I think that question was about what needs to be done, or what would happen to equalise the sort of the playing field.
Well,
I've got go on.
So Ross Brawn is trying to do a lot to try and level that playing field, and the regulations were due to change next year, and some of the teams are already doing very early stage work, I'm sure, on looking at what those cars need to look like. So they've done a lot of analytics. The issue today is it's so difficult to overtake, so they've brought in things like DRS to try and make it more interesting. At Silverstone for the second race, obviously the tyre compounds were softer. I think it was for the second Silverstone one, and it made it more of a race. And I thought, was that Spain last weekend? But I know that Ross texted Martin Brundle through the race and said, changing the tyres is making it a bit more interesting. Certainly, there's an awful lot that's happening in the car that's now going to be the 2022 season. Because of COVID, they're keeping the same cars into next season.
Yeah.
So I think that should help a great deal. DRS is a bit of a cheat to do that, but it's at least given some teams the chance. Love Mercedes to win because I work with them, but it's nice to see Red Bull. We also partner with Red Bull, but we have a Chinese wall. So my colleague that covers that, we don't discuss any of the stuff that we do between teams.
More races would be ideal for F1.
Yes.
I think that's fair to say. Two questions I've always wanted to know since I got into F1. I'm going to butt in here selfishly. I've wanted to know the answer to these two questions for years and years and years of watching races. First one, how much is down to the car? If you had all of the drivers there now, if you had all of the F1 drivers in the same car?
Yeah, I guess you've got that in Formula E, haven't you? Where they've all got the same, and it's a lot. I think I haven't watched Formula E as much. We work with one of the Formula E teams, so Venturi, Formula E out of Monaco, and I think as they went through the season there were different people on the podium almost every week. So that was interesting. It's difficult, isn't it? There are certainly some very good young drivers. I'm sure Mercedes can answer that. George Russell has done lots of time on the simulator up at Brackley, I'm sure, and some of the others, so they will know how close in a simulator or in a test vehicle they can get to what Lewis can do. I think it's consistency that makes the difference. If you look, Valtteri can be very good some weeks, and then he's just not so hot. Lewis has been pretty consistent. I think some of the other drivers, Leclerc, if you look in Ferrari, has been showing Vettel showing Vettel a pretty hard time, definitely this season.
Matt Harris has just commented that drivers do matter, as Lewis versus Valtteri shows, or within any team for sure. Yes, so
Matt's a fairly famous visitor there. So
I know. I'm honoured that we've got Matt here. I'm thinking next guest lineup, Matt.
Yeah, so hopefully, Matt, I haven't said anything you don't approve of. I'm sure I'll be hearing it. But no,
Matt, please join us for another session.
Yeah, so Matt's fantastic. Matt's done some absolutely brilliant customer sessions with us over the last couple of years, and some brilliant stories that he shared with us that have been fantastic. So there's a couple of other questions there. So Rick, too many variables, I guess. Yeah, what advantage do we give them? So that's hard to say. Really, it's us working with Mercedes to get the best, to give them the best from what they're doing themselves. And I say that, and I mean that in the way that I've mentioned that we are technology partners with Red Bull, but we work with some of the other teams as well. We are very strict and very clear internally that we don't take anything that we would learn with one team and share it with another. All right, we would soon be escorted off the premises if we did that. And we respect that example of the machine learning thing. That I believe there's not that many people in Mercedes at the time knew what that use case was. So even within the team, there's probably only a handful of people knew what that was and what we were working on. So we have to absolutely respect that. Obviously, if there's a a common technology, you know, we're probably selling similar hardware platforms for high performance compute to all of the different teams. But if one of them, you know, if Mercedes found a way of getting, you know, an extra 5% out of their platform, we're not going to go and give that to another team, right? So, you know, I hope what we're giving Mercedes, to answer your question, is the right support, the best technology, and helping them understand how to get the best from it. You know, that lap time comes down to lots and lots of different elements around strategy, around tweaking those designs.
And how much do you think that does come down to teams' budget? How much of a difference will we see, do you think, if all teams are on the same
well,
budget?
It's going to, you know, that's,
and
you know,
budget to pay for data analysis and everything.
Yeah. So that's, you know, clearly the big teams are going through, you know, I'm not going to talk any detail, but you know, the bigger teams, the top few teams are currently have budgets that are way in excess of what that cap is going to be next year. So that's going to change a lot of the way that they operate, and how do they, you know, where do they spend the money? You know, whether that's going to make a difference to IT or spares or what, I don't know. We haven't seen that yet. But, you know, if you look back in performance, the budget that Racing Point had, they were definitely getting the very best performance per budget. Right? And now we're seeing that now they've got a bit more budget with the investment from Stroll, that they're way more competitive than they were. Obviously, you know, they've got some of the Mercedes technology in there, and then some linkage, but Williams have that same powertrain and stuff as well, you know. So I think there are some teams just have that, you know, for me, if you look at how well Williams are doing versus Racing Point, I'm not sure of the budget difference between those two, but I think some of it's how well the teams get the value from that. Be interesting to answer that in a couple of years' time when they're all capped at the same level. The team is a well-oiled machine to what extent does HPE use subcontractors? Does it manage supply chain, service delivery? So we've on and off, there's a number of different, as I say, they're a relatively small IT team, but they use a lot of technology. You know, so there's lots of high performance compute, and they do most of that themselves. We've dropped in a full-time data scientist. We drop in specialists for things like networking, or we help them build a private cloud platform. Are those all HP staff? I think most of them are. Obviously, within our consulting business, there are sometimes times that we work with other partners as part of that, but I think that mostly it's certainly been full-time HP staff. So certainly the people embedded in the team are. But it's quite a small ecosystem, right? As I said, that, you know, that the team at Mercedes is 30 people or so. You know, so an awful lot of work to do for a small team. So what we've tried to do is help automate some of that. The edge-centric, so Yanis, edge-centric mantra, push high-performance team on chip AI solutions, but no data scientist backroom support. Right? Will it be down to squeezing AI inference? So you can't do that one. So that's a really good question, not with Mercedes, but that's a conversation I picked up with one of the other teams before the partnership, where we actually have a prototype product in labs called Dot Product Engine, which is an edge inference. So it's a very small processor, and where we use persistent memory to store an inference map. And we were suggesting ideas where we could put AI in the car to do things like automatic brake bias adjustment and these sorts of things. But all of that is banned. So you can't have anything that assists the driver. That was changed. Now, if you look back into Formula One, I can't remember how long ago, but in, you know, the crazy, probably early 2000 era, where there was traction control, crazy launch control, all sorts of stuff, and that was all taken away. So, you know, there's very limited. You can't have driver assistance. There might be some driver assistance to relate with safety. I don't know all the detail, but no, you cannot do that. If you want that, there's a race series called Robo Race, and they actually have a fully autonomous race vehicle that they have one that at the moment has a race driver in it, and another one that can be driven autonomously, and they do a lap with the racing driver and then a lap with just the AI. But their ultimate goal is to have the cars racing just AI with no driver.
Wow.
Next one, what's the process to create completely new parts or components? Do you engage in those challenges mid-season? That's going on all the time. So we don't have a great deal of involvement with that other than providing the compute to model it. But, you know, it is a DevOps business, right? So if they see something changing, they will be creating a new side pod or a little aero package, or they will have probably got a number of things they were planning to do during the season, but there will be probably, I would guess, new parts at every race, and you wouldn't see them. I know Matt, when we've been there, has pointed them out occasionally from one race to the next when we do a factory tour, or as to a little change here or a change there. So the car, I would say, is different every race by some small degree. A big change like a wing or something like that, maybe less so, because they've got to stay within the regulations and they're pretty restrictive. So how quickly can you improve and innovate the heat challenge? So I don't know if that the anonymous attendee, whether that's relating. I don't get to see as much of this data. I used to be able, when we were in the factory, I could go to the Monday debriefings and hear a bit more. We've had people like Andy Shovlin would give us a bit of a view. Unfortunately, I'm not getting to listen to those now, which is a shame. I do miss the opportunity to that. Obviously, the team have been challenged with blisters on the tyres and things over the last few races. There were certainly issues last year of those, you remember, with the cooling challenge in Austria. I think they actually had to cut some slightly bigger holes in the side pods or something for that one. But if there is a challenge like that, there was one that they spoke about openly that I think I mentioned in Austria with the vibration off the curbs. The team were working on that from seeing it, I would guess, in free practice on Friday morning to get some sort of resolution out, if not that weekend, certainly for the following weekend. So there will be people working on those things straight away. So Peter Craft, other restrictions on the IT equipment. Not all the IT equipment is restricted. That's mostly the high performance compute platform. So the clock speed, it's a bit more complicated than clock speed and number of calls, but also the number of hours that they can run it for, and those are going to be a bit more restricted in the future. So another anonymous one about computer science and finance. How do you get into the team? I did a show called Viva. Yeah, I did a show called Viva Tech, which in Paris last year, which had 120,000 people on it, and that was the question I was asked every 10 minutes. And I did ask a couple of people in the team. They do a graduate program. Have a look on the website. There's usually details of it on there. And I think you can subscribe either, if not there, then on LinkedIn. Amazing place to get into. They do apprenticeships as well, so I know they take on apprenticeships in different parts of the business. So certainly, have a look at that. If you've got a computer science degree or something, take a look. Amazing graduate program. Going to be pretty tough to get in, I'd imagine. So next one, Sam Shirin. Is there a link between data modeling, machine learning between physical races and virtual F1? I don't know the answer to that one, as to how much you can change. Certainly when I look at Formula E, they can't change anything. They've all got the same car. Obviously in esports, I've not followed that as far. I'm assuming you're given a car and you can change the setup of the car. You probably can't change the aero packages and stuff. Not an area I know, unfortunately. So what's the next one? I think, John, fans would benefit from seeing more data being exposed. I think the FIA are doing that. You're seeing an awful lot more that's being presented. They're doing simulation of windows to overtake, all of that sort of stuff. So there's a lot more data that is being shared. And, I think the audience is changing. The FIA need to make it a lot more engaging. And I think that view with esports and a bit of controversy about which of the Formula One drivers will do esports or not. I found it interesting during shutdown to watch some of the guys doing that and who was doing well and who wasn't. Some of the younger guys still getting engaged, but the more mature ones not wanting to maybe expose themselves. So it's a personal view.
So that question goes back to what we were chatting about earlier before it started about how, at least in my opinion, the best bit of F1 used to be listening to the talk and the conversations between the engineers and the teams and the drivers and really hearing everything of what they were saying. You heard so much more and just felt so much a part of the team and the drive and what was going on. So for me, when that changed and there was less communication allowed, that really not ruined F1, but that detracted a little bit of the fun for me. And the more you can see.
Not live in the race, but I know Mercedes, I think Andy Shovlin or James Vowles does them on LinkedIn. And I think maybe on Facebook, they do a little weekly video of questions. So you can ask questions around strategy, what happened in the race.
It's not the same though. It's not the
it's
same.
not live,
live.
no, but it's interesting, you know, and it was, you know, the opportunities I had to listen to some of those at the factory were really fascinating, you know, to hear that little bit of why did you do that.
Yeah.
Were really interesting, yeah. So Mark, when are you going to sign Vettel? Not me, I work for HPE, but I think Lewis and Valtteri are both safe for next year. I'd quite like to see George Russell get back in with a seat, actually. I think that would be quite interesting. Is machine learning used live in the race update strategy? Would I say machine learning? You're probably in places I can't talk about and maybe don't know in all the detail. There is an awful lot of work looking at real-time strategy. Lots and lots of stuff goes on. As I said earlier, you know, that all of that is being looked at real time, and then with a gut feel from James Vowles added to that. I think certainly looking at, you know, whether you call that machine learning. So the team have been, you know, very clear to us on what they agree machine learning is or isn't, and what they would agree is artificial intelligence. Certainly looking at a number of things in that space. Was Stuart just expanding that using open loop input from the racetrack?
That's a comment. There's a few questions in the chat. How often in a single season do you move engineers from Valtteri's side of the garage to Lewis's side, and vice versa, or do you at all, or is it fixed teams?
I don't know that. I'd expect they'd be relatively fixed.
Matt just answered never within season.
Yeah, although if someone breaks the car, I imagine it's all hands on deck. So thank you for Matt on that. Yeah, there's bits of the team that thank you for Matt on commenting. I don't know. Obviously, I'm more in the IT side. I think Matt in his early days was actually on a wheel gun or something in the pit crew. So that was a fairly interesting IT role for Matt when he was doing it.
Cool. No, brilliant. Thank you so much. Matt's just saying he cleaned the side pod.
He cleaned the side pods. That's a fairly safe job, right?
Put you back on Spotlight video, it went to me. There were a few more questions in the chat. I'm just going up to.
God, there were lots in there, weren't there? Right, sorry.
Yeah, there were. The team are using AI to measure and optimize a number of factors, and are HPE providing infrastructure for this, or do you use cloud services and other tools?
So that's currently all being run on site. I think there's certainly evaluation of looking at what makes sense to run on cloud. You know, so you know, our view, whilst we're an infrastructure business, we've also got a hybrid IT business that will build things that are cloud native. So we acquired a company in the UK a few years ago called Red Pixie, who were an Azure cloud first business. And that's some of the team that have got engaged occasionally with Mercedes. So, you know, there are some things that it makes a lot of sense to run on site with infrastructure. There are other things, if you're looking to evaluate them, that maybe it's better to prove out there. But I think currently, most, if not all, of the use cases have been on site. And some of that, you know, we're using to prove out, you know, we've got a platform in particular, an Apollo system that can take 6 or 8 big GPUs, right? So it's a pretty monstrous AI platform. So, you know, we're looking to prove out some of these use cases. And also for some customers provide those on a consumption basis. So we can put equipment on site and charge per GPU hour kind of model. Yeah, because there's obviously an issue around data sovereignty. You know, so the issue of some of the IP that any of these race teams have got or other manufacturers would not necessarily want to do on a public cloud.
Cool, thank you. That's just added that they use cloud for burst requirements for compute, but not machine learning, and that mainly for race simulations. Matt also said above that the issue with the sort of the commentary that we were talking about is that teams try and restrict what's shared so other teams can't learn. So I'm going to interject with a question about that. How clean is F1 about relationships between teams? Is there a lot of trying to steal data and information from each other?
I don't think so.
Work?
I think there's more of a gentleman's agreement, and there was, I can't remember the teams now, there was an issue, but was it Red Bull and Ferrari? Or McLaren, I can't remember who it was, but a few years ago there was an issue where the teams actually got fined, I think, where an engineer had left one company and taken IP. Yeah. But I don't think they would accept it. Certainly, 200 million. Yeah, you know, I don't think. You know, some of the conversations I've had with the R&D team, you know, Mercedes, I guess they'd all do this. So some of the issues that I've seen won't mention what it is just in case that's sensitive, but when Mercedes had found in their work to look at what could be done on a certain design part of the car and the testing the FIA were requiring, they'd found a way to effectively cheat and get around the rule. Right? It was adding stiffness to a certain design. And they actually said, we took that to the FIA and told them they needed to change the testing methodology to stop that being done as a cheat. Right? And things like that, so is it DAS, the steering adjustment, you know, Mercedes worked with the FIA on that beforehand, or it's been banned for future seasons. But I think, you know, and particularly with Mercedes, I think the parent ownership with Daimler would mean there's no way that they would ever want an accusation of taking any IP from another company.
Yeah.
And they have, you know, restrictions, quite long gardening leave issues and things like that. You know, someone depending on the position in the company, you know, 3-6 months kind of thing before you can join. So you're effectively in the next season.
Right. No, thank you so much. So Ian, so grateful to you for all of that. Well, it was absolutely amazing. I know I'm not the only F1 geek and obsessed fanatic in here, so that's been super, super interesting. Thank you so much for joining us. Super grateful also to Matt.
Yes, thank you,
from
Matt.
the Mercedes team for joining in. Matt, you have an old shirt on, Ian.
Yes, yes. Yeah, feel free to send me a new one, Matt. Yeah.
Matt, what do event organisers need to do to be sent a shirt as well? But no, thank you so much, Ian. That's been really, really interesting. Thanks for your time and giving us all the answers to all of those questions. Super interesting.
No, thank you.
So we'll,
really interesting.
Share this out afterwards, but really grateful to you for joining us. Matt posted some comments about how useful HPE have been to the Mercedes team for everything that you've done. So that's very cool to hear. Grateful to you for giving up your time and for all that you're doing. And yeah, just very much hope that soon maybe we can, I don't know, have a crypto carry club.
Yes.
Emerging tech networking events, meet up at Brackley or somewhere or something in real life again. But thank you so much for your time. Really grateful. Thanks for everyone for giving up their time and asking so many amazing questions. And hopefully speak to you again soon.
Thank you.
Thank you.